Let's take a look at the next example. We have example 3 there, and it says chlorine gas is prepared by the following reaction. Chlorine gas is prepared by the following reaction. Sodium chloride plus MnO2, that's manganese 4 oxide, plus 3 moles of H2SO4 to give us manganese sulfate plus sodium hydrogen sulfate plus chlorine plus water. And we have a question saying, what weight of MnO2 is needed to produce 350 cm³ of chlorine at STP? What weight of MnO2, that's manganese 4 oxide, is needed to produce 350 cm³ of chlorine? So what do we do about that? What we need to do is to check first if the equation is balanced. If it is balanced, then we proceed. And if it is not, we balance it. But from what we can see, the equation is balanced for us. So since the equation is balanced, look at what we have in the bracket. We are told FW of MnO2 is 86.94. That is the same formula weight. That's the meaning of FW, formula weight of MnO2. Formula weight is something as molar mass. That's molecular mass. The mm of MnO2, the molecular mass of MnO2 is 86.94 grams. So what it simply tells us is they have done that part of the job for us, so we don't need to go ahead calculating the molar mass of MnO2 again, since we already have it as 86.94. So looking at the question, we need to ask ourselves, who are the species I am most interested in? From the question, it is clear that we are interested in MnO2 and chlorine, because the question says, what weight of MnO2 is needed to produce 350 cm³ of chlorine? So let us proceed. So looking at how to solve that question, we have this now. Let's take this a little. So we have from the equation, we have MnO2. We're interested in MnO2 and chlorine. And looking at that equation, 1 mole of MnO2 is producing 1 mole of chlorine. MnO2 is at the reactant side, chlorine is at the product side. So we are interested in MnO2 and chlorine. So let us proceed. From what we have from the equation, which is already balanced for us, we are told that the formula weight, that is the molar mass of MnO2, is 86.94. That is to say, 86.94 grams of MnO2 produces a quantity of chlorine, which we don't know. But we can go ahead calculating that of chlorine. Chlorine is 35.5, but there are 2 atoms there, so it's going to be 35.5 times 2. And 35.5 times 2 is 71 grams. So it means that 86.94 grams of MnO2 produces 71 grams of chlorine from the equation. Now the question says, what mass of MnO2 do we need to produce 350 cm³ of chlorine gas? So can you see that? What mass of MnO2, what mass, grams, of MnO2 are we going to be needing to produce 350 cm³ of chlorine gas? Now, how do we go about solving that question? Looking at chlorine, we have just solved 71 grams of chlorine. That is to say, 86.94 grams of MnO2 produces 71 grams of chlorine. But the question actually wants us to find the mass of MnO2 that will produce 350 cm³ of chlorine. Since the question is talking about volume of chlorine, then it means we have to focus our attention on the volume of 71 grams of chlorine so that it can tally with 350 cm cube. So the two parameters ought to tally. Since we are not really interested in mass of the chlorine, but we are interested in calculating mass of MnO2. So what we simply need to do is this. From what we can see, 71 grams of chlorine is just equivalent to 1 mole. It's just the same thing as 1 mole of chlorine. And we have been made to understand that 1 mole of any gas is 22.4 dm cube. So if that is the case, what we can simply say therefore is this 71 grams of chlorine we are seeing here is the same thing as 22.4 dm cube. That is it, 22.4 dm cube. So we are now trying to make it mass-volume relationship. Since the question talked about volume of chlorine, 350 cm cube, we have to forego or close our eyes on mass of chlorine and focus on the volume. And the volume of chlorine is 1 mole of the gas there. Since it is 1 mole, it means 1 mole of chlorine is 22.4 dm cube. It's a constant. So since we have established that fact, we need to now convert dm cube to cm cube, since we have been given 350 cm cube from the question. So to do that, we simply say we multiply by 1000 times 1000 so that it gives us our value in cm cube. And when we multiply 22.4 dm cube times 1000, it gives us 22,400 cm cube. That is, taking decimal one place, we have 224 times 100, and 224 times 100 will give us 22400. So this is our value, 22,400 cm cube. So what this simply means is this. From the equation, 86.94 grams of MnO2 produces 22,400 cm cube of chlorine. Now the question comes, how many mass, what mass of MnO2 will give us 350 cm cube of chlorine? That is the question. And we have established what will give us our answer. So with that, let us cross multiply. Cross multiplying now, we have 22,400 times x is equal to 86.94 times 350 cm cube. So this gives us 22,400. It's going to be just 2 zeros, not 1 0. So 22,400x is equal to 86.94 times 350. What does it give us? 86.94 times 350. That gives us 30429. 30429. That's what it gives us. So our x will be dividing both sides by 22,400. 22,400 22,400. So this can take care of this, and our x will become 30429 divide 22,400. That gives us 1.36 grams. It gives us 1.36 grams, approximately 1.36 grams. So the mass of MnO2 that will be needed to produce 350 grams, 350 cm cube of chlorine is 1.36, approximately 1.36 grams. So that is what we have there. So let us take a look at what has been solved. for better understanding. So we have MnO2 and chlorine. So 86.94 to give us 71 grams, and 71 grams is equivalent to 22.4 dm cube, which is something that's 22,400 cm cube. And then we have it as this. As you can see, at the end of everything, we have X is equal to 1.358 grams, which is approximately 1.36 grams of MnO2. So this is actually how to solve different questions under stoichiometry.